Hi, I'm Reid, the founder and co-owner of Lune Croissanterie in Melbourne, Australia. Before I founded Lune, I was actually working as an aerodynamicist in Formula One. My unique background has given me the skill to reverse engineer the croissant with great precision. Here at Lune, there are a lot of numbers involved in making a croissant. We control the humidity in the raw pastry room, we set specific temperatures for the provers and ovens, and we precisely weigh every single ingredient. It feels a little like a new era for pastry steeped in tradition. In a similar way, the new Porsche Taycan continues the tradition of the Porsche sports car, but instead of filling it with petrol, you charge it with electricity. It has the soul of a Porsche, it handles like a sports car, but when you're talking about the Taycan, there are a lot of new numbers that come up, especially when talking about charging the car. Today, I'm going to explain what some of them mean. Let's start with the battery. The Taycan Turbo and Taycan Turbo S are equipped with a 93.4 kilowatt-hour performance battery plus, which is available as an option on the Taycan 4S. A kilowatt-hour is a unit of energy, meaning the higher the number, the more energy that can be stored. However, charging a battery is not quite as simple as filling up an empty fuel tank. Temperature and state of charge can have an impact on a high voltage battery. This applies both to the absorption of energy when charging as well as energy output in the form of acceleration. The performance potential is at its peak in a specific temperature window. Selecting the fast charger you're planning to charge at in the navigation system ensures the battery is at this optimum temperature for charging when you arrive, regardless of the ambient temperature. As you can see on this graph, if the battery temperature is not at its optimum, then charging times may extend. The state of charge of the battery is the percentage of how much energy capacity is stored in the battery. This chart shows a scenario using an ultra-rapid charger. You can see the charging power, displayed here in kilowatts, in relation to the percentage of the state of charge. At the beginning, the battery can take a lot of charging power until it reaches its peak at 270 kilowatts. As you can see on the graph, towards the end of packing all that energy into the battery, the charging power slows down in order to protect the longevity of the battery. It's a little bit like pouring a latte. Right at the end, the barista slows down in order not to spill the milk and absolutely nail that latte art. It's not all about the battery capacity though. Of course, a decent-sized battery allows for greater energy storage and release, but charging times also depend on the system that is used to get this energy into and out of the battery. The Taycan is the first production electric vehicle with an 800-volt system instead of the usual 400 volts for many electrical cars. Using an 800-volt system enables consistent high performance, not only when it comes to charging the Taycan. It also decreases the weight and installation space needed for cabling and enhances performance. With the 93.4 kilowatt-hour performance battery plus as standard in the Taycan Turbo and the Taycan Turbo S, the 800-volt system allows a maximum peak charging capacity of 270 kilowatts. What does that mean? Let's compare electricity to water. The current is the speed at which the water flows. The voltage is the pressure at which water flows. The kilowatt is the power output. Current times voltage equals power, which is measured in kilowatts. For example, a current of 335 amps at 400 volts will result in approximately 134 kilowatts of power output. Compare this to the same current at 335 amps, but with 800 volts. That will result in approximately 268 kilowatts of power output. This means an 800-volt system can work at double the capacity of a 400-volt system, provided the current is equal, the power output will be higher. This all means faster charging times. The 800-volt system not only means the power goes in faster, it also comes out faster. It means enhanced performance, especially acceleration. The same amount of amp flowing through the cables at double the voltage also means less bulky cables are required, saving weight and space. Recharging speed not only depends on the car, but also the charging infrastructure you're using. There are different types of ultra-rapid or fast chargers, like the direct current or DC 800 volt charger and the DC 400 volt charger. These fast chargers have different power outputs. For example, here in Australia on the ChargeFox network, a typical ultra-rapid 800 volt charger can have up to 350 kilowatts of power output, and the 400 volt fast charger typically has around about 50 kilowatts of power output. The power output depends on the amps available from the type of charger or outlet being used. Remember that formula from before? Amp or current times volt equals power? A change in the current would affect the power output and hence the time it takes to charge the car. I know these are a lot of numbers, but I promise you it will all make sense. All right, here's an example. In relation to the Taycan, an 800 volt charger would need around 338 amps in order to charge the Taycan at peak recharging power of 270 kilowatts. Provided the battery is at the right temperature and right state of charge, as I explained earlier. But what happens if you plug an 800 volt system like the Taycan into a 400 volt charger? In order for the 800 volt system to receive and store electricity from a 400 volt charger, the Taycan uses an onboard DC charger to double the voltage and halve the current. Pretty clever, huh? The 150 kilowatt onboard DC charger that is standard in the Taycan in Australia does this, delivering approximately 3 times faster charging times compared to a 50 kilowatt onboard DC charger. If you're not around a DC ultra rapid or fast charger, then you can also charge at alternating current or AC charging stations, such as the Porsche destination charger, for example. In this case, the Taycan uses the 11 kilowatt onboard AC charger for the optimum charging performance. Of course, compared to an ultra-rapid and fast DC chargers, charging times at AC chargers are slower, around 9 hours, to charge for a 400 volt AC industrial 3-phase socket with 16 amp of current and 11 kilowatt of power output. The Porsche destination charger is also similar to what Taycan owners may install at home to charge their car. Your Porsche Centre can connect you with the right expert that can assess your infrastructure at home in order to provide the best possible charging options. I hope I've managed to demystify some of the numbers around charging an electric car. Thank you for your attention. At the end of the day, the most important thing about the Taycan is it is still a true Porsche sports car. It has the soul of a Porsche, electrified.